Hi, this is Bobby Jo Williams, and this is my abstract assignment for an empirical peer-reviewed research article. This is my math RBI article evaluation. The article's title is Selecting Effective Interventions to Increase Math Computation Fluency by a Brief Experimental Analysis. The study design uses the Brief Experimental Analysis, or BEA, and this is an empirically supported assessment procedure that determines the success of interventions. It tests students' response to interventions prior to extended implementation. It uses a brief multi-element design to quickly test the effects of multiple intervention components, and it quickly identifies interventions that remain effective when implemented over numerous sessions. So the purpose of the study was to have some more research done on the BEA, or the brief experimental analysis of certain interventions. There's quite a few supported articles and research-based programs that BEA has already done with like oral reading fluency interventions, but there really haven't been any effective fluency for math interventions done by using the brief experimental analysis method. So this was to add to that research. And the researchers asked three particular questions. Will students demonstrate differential responding to math fluency interventions during a BEA of the interventions? Number two, will students' response to an intervention during the BEA predict students' response to an intervention during an extended analysis? And finally, will the interventions identified as most effective during the extended analysis continue to produce the improvements in math computation fluency during an intervention phase in which the most effective intervention is implemented in isolation? So the subjects that were studied, well, actually this was a research study on two individual studies, and the first study had 4 subjects, and those subjects were recruited from general and special education classrooms. They were nominated by their teacher or the school's RTI team if there was identifiers in math deficiencies for these students. So the first study had an 11-year-old Caucasian male from a general education classroom. His name was Chris. Adam, a 12-year-old Caucasian male general education student. Doris, a 10-year-old African-American female receiving special education services for SLD in math reasoning, and Irene, a 12-year-old African-American female from the general education classroom. In the second study, there were also 4 particular participants. The first one was an 8-year-old Caucasian male, and the next one was, his name was Kyle. The next one was a 7-year-old Caucasian male named Patrick, an 8-year-old Caucasian female named Julie, and a 7-year-old Caucasian male named Mark. All of these participants in the second study never received any prior math intervention services at school. Okay, so the explanation of the problem, or the purpose behind the study, as I told you in the beginning, was that they had some of these studies conducted for reading, especially oral fluency, using the BEA method, but there weren't very many for math fact fluency, and the researchers determined that many school-age children with and without disabilities struggle in math. There were 50% of children in special education services that have an IEP with a math goal. And then NAEP also found that 42% of 4th graders are proficient in math, and that would mean 58% are not. A study of 14-year-old general education students revealed that 85% mastered addition, 81% mastered subtraction. what was astounding to me was that approximately 50% were found to have mastered multiplication and division, which means half could not master their multiplication and division facts. Okay, so the dependent variable in both of the studies were different. So in study 1, they used the CDPM, or correct digits per minute, using a standard curriculum-based measure in math for that dependent variable. And the formula listed there, the number of digits correct divided by the number of seconds worked times 60, gave them their correct digits per minute. In study 2, they used the total correct digits, or you'll see it as CD, completed in 2 minutes on the Ames Web grade level math computation probes. So the study, or the independent variable, was set up with a multi-element design. So they have the screening, which took place first, the baseline, reward condition, cover copy compare condition, constant time delay condition, and then there was a control condition. After that, the extended analysis kicked in, and finally the student was placed into the intervention phase. Each of these independent variables are marked out here. The screening condition was where students performed at the frustrational level of performance for math, which is defined as completing 0 to 19 correct digits per minute in grades 4 and above. And then the baseline was taken, where the students had to complete at least 3 math computation fluency probes that included randomly generated multiplication and division facts. They continued until the performance remained stable or a decreasing trend was evident from at least 3 sessions. You'll be able to see some of this in the graphs that I have included at the end of the slides. So after the screening and baseline conditions, went to reward condition, where a unique set of multiplication and division facts were randomly assigned. Students were allowed to choose a reward contingent upon a predetermined CDPM score. Those goals were determined by multiplying the student's baseline score by 1.25 for a 25% increase. Then next was the cover copy compare condition, and this is where participants completed multiplication and division facts using the CCC procedure. Prompting was used to ensure accuracy of implementation. Immediately following this phase, a CBM probe was administered using the same CCC probes. Next was the constant time delay condition. Randomly selected multiplication and division facts were given to the students on 4x6 index cards, and students were read aloud or students were asked to read aloud and answer the questions. The presenter prompted after 0 seconds the first 2 trials. So if the student didn't know or didn't get it right, immediately the presenter would prompt. But after, during the 3rd trial, they waited a 3-second delay until they prompted. Immediately after the intervention session, one of the curriculum-based measures for math probe was assigned and scored. Next was the control phase, and this is where no instructional components or feedback was provided, and the students would complete a completely unique set of multiplication and division facts. Once they went into the extended analysis phase, they were put in here, and after the BEA, rapid alternation of the most and least effective conditions were implemented in random order 3 to 5 times per week for 20-minute sessions. Then the students reached the intervention phase. The intervention deemed most effective during the conditions was implemented in isolation to demonstrate continued effectiveness. During the BEA, the article mentioned that there was a withdrawal phase in the first study, but there really wasn't any detail or information given as to when that withdrawal phase occurred and what they did following that withdrawal phase to determine, the effects of it. So study 2 then, the independent variable, was similar to study 1 with the exception of the extended analysis following the BEA without a withdrawal phase. So again, they mention this withdrawal phase, but they don't really ever go into any detail about where it occurs within the study. And then there was no control condition for study 2. So the methodology or measurement was that the researchers specifically measured the change in the dependent variable with the following assessments. In study 1, CDPM using standard CBM procedures for math. In study 2, CD or correct digits completed in 2 minutes on the Ames Web grade level math computation probes. The reliability and validity of study 1, independent scorers were graduate students in school psychology and were trained to conduct CBM procedures prior to the study. Agreement during training sessions had to be above 90% before being allowed to participate in the study. A treatment integrity checklist was developed for each intervention condition as well as the control. And the treatment integrity was expressed as the percentage of procedural steps completed accurately. And the procedural integrity for all conditions ranged from 94% to 99.29%. Finally, the results. The results of the 2 studies concluded the following answers to the research questions that were formulated at the start. So the answer to question number 1, will the students demonstrate differential responding to math fluency interventions during a BEA of the interventions? The results were mixed. Only 2 of the 8 participants displayed differential responses to interventions during the BEA. For question number 2, will students' response to an intervention during the BEA predict students' response to an intervention during an extended analysis? The results were more favorable. 6 of 8 students showed that the intervention with the greatest rate during the BEA was also the intervention with the greatest rate during the extended analysis. And the last question, will interventions identified as most effective during the extended analysis continue to produce improvements in math computation during an intervention phase in which the most effective intervention is implemented in isolation? The answer to that was that they are very favorable, showing that that is indeed happening. And finally, here we have 2 figures. Figure 1 on the left is from the first study with our 4 participants. And our 3rd participant down is actually Doris. And she was our special education student, which I talk about a little bit more in our limitations and evaluation of this study. And then the second one on the right was from study 2, where you can see the BEA, the baseline, and the conditions being implemented, and then the intervention phase showing the most and least effective being done in isolation. So our discussion was that the present studies provide additional support for the use of BEA to quickly identify interventions that will produce improvements in student performance across numerous sessions. They provide support for Tier 3 intervention procedures when choosing a math intervention program. And again, to me, of course, it was all about your progress monitoring. That's what they're doing during those conditions, and then checking the results of that at the end to find the most effective. The authors of these studies compared the results to that of another study, which also conducted BEA and found similar results. This suggests that BEA is an effective method for finding math fluency interventions that are able to be generalized over numerous sessions. I'm going to stop here and continue with another screencast.